In this video, we'll demonstrate the cable sizing function. The relevant study case should be active. Cable sizing can be used to verify existing cable types in the network and to make recommendations that will allow voltage, thermal loading, and short-circuit constraints to be met. We'll be carrying out the analysis for feeder FD126, and here you can see a schematic diagram of this feeder. The cable sizing command is accessed from the Cable Analysis toolbox. Let's look at the options. There are two modes: verification, where the existing cable types are assessed, and recommendation, where cable types or parallelization options are suggested. Where cable types are to be recommended, these can either be created according to the selected standard or taken from a selection of types provided by the user. To start with, we'll carry out a verification. With this option selected, derating factors will be calculated according to the specified standard, in this case IEC 60364. If we look at one of the line segments in the feeder, we can see the general installation and environment conditions, and on the relevant tab, the parameters for the specified standard. The low voltage load flow will be used. If you're not familiar with this particular load flow calculation, there are two other videos in this playlist that show what it does. The balanced network representation is selected. On the Constraints page, we've selected the option Thermal Constraints and a maximum thermal loading of 80%. A lower voltage limit of 0.94 per unit is set for all terminals in the feeder. We'll now execute the command. For information, the derating factors are shown in the output window. We can also see that thermal and voltage limits are violated. This can be shown in a voltage profile plot for the feeder. The thermal and voltage violations are apparent. The output of the assessment can also be seen in a report. In the first section, any cables that exceed the thermal loading units are identified. The second section shows all terminals in the feeder where voltage constraints are violated. A number of terminals are reported, with the lowest voltage being 0.911 per unit. To improve this situation, upgrading cable types or introducing parallel circuits might be considered. Let's return to the cable sizing command to carry out the recommendation process. We select Recommendation and will use a user-defined selection of cable types held in the project. As well as all the technical parameters, note that costs have been entered, which will be taken into account when cable types are selected by the cable sizing tool. In addition to these costs, there will be installation costs. These are specific to each cable and so are supplied in the line element. On the Constraints page, we'll use the same options as before. On the Recommendation Options page, Parallel Lines tab, we've selected the option to allow parallel lines to be created in addition to improving the cable types. The option selected here means that creating parallel lines will be the first choice, and only if the maximum number of parallel lines does not solve the problem will the cable cross-section be increased. On the output page, the Modify Cables box is checked with the option to create a new variation with recommended cables. The command is executed. You can see that a new variation has been created and activated containing the new cable recommendations. Let's look at the reports from the recommendation process. The first part is the verification of the original state, as we saw before. On this page, we see the cable changes that have been recommended. In some cases, the recommendation is the introduction of parallel circuits. The last section of the report shows the reinforcement costs. Let's look again at the voltage profile. We can see that there are now no thermal or voltage violations in the feeder.